Welcome to this session. We have an integral as to evaluate. So the integral of dx over x squared minus 6x plus 11 squared. Now the trick on this integral is to express the denominator as a sum of two squares and then use trigonometric substitution to solve the resulting integrand. So this is what I mean. So we say we use completing the square method to express x squared minus 6x plus 11 as a sum of two squares then apply trigonometric substitution. Now this is how we complete the square. So we have x squared minus 6x plus 11. Now when you have a quadratic expression of the form x squared plus bx plus c, to complete the square, you simply take b over 2, square it, add on these terms, and then balance so that the value of the constants agrees with the original expression. So our b here is minus 6. So minus 6 divided by 2 is minus 3. So that minus 3 minus 6x, then minus 3 plus minus 3 squared, and then so minus 3 squared is 9. So we have added 9, but this would be 11. So we need to add 2 so that the original expression has the same value. Now this part, after doing that one, now will be a square. So bx minus 3 square, then plus 2. And you see this can be written as x minus 3 squared plus root 2 squared. Once we have that one, so this is what we have as x squared minus 6x plus 11. Then say let u to be x minus 3. So which means du is equals to dx. Now the integral dx over x squared minus 6x plus 11 squared is the same as, where does dx you put du, and then over this is the same as, now in terms of u, this is the same as u squared plus root 2 squared. So you'll have u squared plus 2 and then u square. So this now is where we apply the trigonometric substitution at this point here. We then evaluate the u integral. Now this new integral in terms of u, the u integral using trigonometric substitution. And then since we have only 3 trigonometric substitutions, we have x squared plus x squared, and then where integrals of the form x squared minus x squared, and where you have the integrals of the form x squared minus a squared. Now, because this sign is plus, so this actually is the correct choice. So we use, and remember when we have this, we have to take x equals to, okay, let's be u. So here we pick u to be a tan of theta. Here we pick u to be a sin theta. And here we pick u to be a sec theta. So we let u to be given by a tan theta. What's that? This is sine plus plus. And where our a, comparing this and this one here, a is given by √2. So which means that you are going to pick u is √2 tan of theta. And then when you say square root of u squared plus 2, it is the square root of 2 tan squared theta plus 2, which is square root of 2 into tan squared theta plus 1, which is the square root of 2. Tan squared plus 1 is sec squared theta. So this implies square root of u squared plus 2 is equals to √2 sec theta. Now du will be given by, from this will be √2 sec squared theta d theta. So thus the integral du over u squared plus 2 squared is the same as integral of √2 sec squared theta d theta. I remember this is square root of u squared plus 2 is what is √2 sec theta. So if I square is when I get u squared plus 2. So which means that when we have u squared plus 2 squared, I have to raise this one to power 4. So I'll have √2 sec theta, then raise power 4. So which will give me integral of √2 sec squared theta d theta. Raising to power 4, I'll get here to be 4 sec power 4 theta, which will be the integral. I factor out, okay, so this will be √2 over 4, and then so I have d theta over sec squared theta, which is √2 over 4 integral of cos squared theta d theta. And to carry out this integration, I'll have √2 over 4 integral of 1 plus cos of 2 theta over 2, and then the theta. So which will give me, factoring out 2, so I'll have root 2 over 8 integral 1 plus cosine of 2 theta, the theta. And you see, this will give me root 2 over 8. This will be theta, plus this will give me sine of 2 theta divided by 2, and then plus c. But you see, sine 2 theta the same as 2 cos theta sine theta. So that 2 and this 2 cancels out. So I'll have root 2 over 8 theta plus sine of theta cos of theta. And then plus c. But we don't stop here because theta was not in the question. So remember, we have u is the same as root 2 tan theta. So it means tan theta is the same as u over root 2. So if you draw a right angled triangle, this is theta. So opposite is u, adjacent is root 2. So this is the square root of 2 plus u squared, or u squared plus 2. So from this triangle, or from this one here, we have theta is tan inverse of u over root 2, and sine theta is u over root u squared plus 2, and cosine of theta is root 2 over root u squared plus 2. So because our integral was root 2 over 8, so we'll have root 2 over 8 into theta, which is tan inverse of u over root 2, and then sine theta plus cos theta, so plus, so u over root u squared plus 2 times cos is root u root 2 over square root of u squared plus 1, and then plus c. So which you can write as root 2 over 8 tan inverse. Remember, u was x minus 3 over root 2, and then plus the same as root 2 times u, which is x minus 3 divided by, so u squared, so we'll have x minus 3 squared plus, this is 2, plus 2 is the same original expression of x squared minus 6x, and then plus 11. So we'll have x squared minus 6x plus 11. And then we add a constant of integration, 3. So that is the solution to that particular problem. Thank you.